Assalamu alaikum wa rahmatullahi ta'ala barakatuh. I'm very sorry today our class is going to be very brief, and inshallah we just have to manage. So today we'll be talking about mesomeric effect. Mesomeric effect is also referred to as resonance. This deals with the delocalization of pi electrons within a compound. Why do they undergo this delocalization? They undergo this delocalization in order to attain stability. For example, for even in human, we move to attain stability when during this lockdown period, those that are working for private schools and other things, so they discover that now they are on lockdown, there will be no payment, there is no money, so they have to change work and look for another thing doing. So this we are all students in school before, but during this lockdown now, everybody find one or two things to do to earn a living. So that is, you are changing from one thing to another just to attain a great stability. So now, for example, now if you watch this is a compound. This place is highly unstable, because that's why the reason why it is positive. So this place is rich, so it will transfer this bond to this side. So by the time it transfer the bond to this side, this place becomes stable and this place become unstable. After some time, this bond will come back to this place and return here. So that's why you see the arrow is facing both front and back, meaning it will change to this form, and after some time it will change back to this form, just to make the compound stable. Look at the second one. This bond will come to this place, and then this one will move to this place, then it will be like this. So after some time, when this one will go back here, and this place will become negative again. So that's how they will continue resonating until to be attaining stability. The same thing here. If you check this one, this place is unstable, so this one will transfer to this one. If this one transfers to this one will become deficient, unstable. Therefore, this one will also transfer his own to this one, and he will become unstable. Then the reverse will be the case. This one will transfer it back here, and then this one will transfer it back here, and it will attain back this compound. So that is how resonance occur in aliphatic compound, that's straight chain compound. So but it also occur in aromatic compound. So mesomeric effect in aromatic compound, there are some notable information. It is good to note that in aromatic compounds, the movement is usually via half-head arrow. This is how the half-head arrow look like. It's also observed at the table below. So when the bond is leaving, when the arrow is leaving a bond and landing on an atom, it deposits a negative charge. When it is leaving an atom and dropping on a bond, it gives a bond. When the arrow is leaving an atom and landing on a bond, then it will drop a bond there. So take note of this. Let's see how practicalize it. Now the one in red is always moving from atom to bond, while the one is in black is always moving from bond to atom. So we say when it leaves an atom, you see leave an atom and land on a bond, it will deposit another bond. So that's why it is depositing another bond here. Okay, and we say when it is leaving a bond and landing on an atom, it deposits a negative. So now it is leaving a bond and it's landing on an atom. That's why it deposits this negative. Now the movement continues. The red biro moving from atom. So it moved from this atom, and it's landing on a bond, so it will deposit another bond. That's the bond here now. I hope you can see it. The bond is there in red biro. This is the bond. So, and then this one now moves from bond, it's leaving a bond and it's landing on an atom. Therefore, it deposits what? A negative. It deposits a negative here. So now it continues. This arrow again move from atom to a bond. We say from atom to a bond will deposit another bond. So that's why we are having another bond here. You see? Then the other one is leaving bond to atom, which will deposit a negative. So it is leaving a bond, and to atom it deposits a negative. This is the negative. And then again from atom to bond, and it will deposit a bond. Alright, so we have the last structure. Alright, now let's see. This bond will maintain its position. Now this one also maintain its position. Now here again, from atom to bond, it will deposit another bond. So it will deposit another bond. And now this bond to atom will deposit a negative. So now it deposits a negative. You can see it has come back to the way it is before, but with an inversion. This one coming back here, this one coming back here, and this one going back here. So this is a one complete resonance. Let me repeat it. From bond to atom will always deposit negative, and atom to bond will always deposit a bond. So the first move is from atom to bond, which deposit a double bond, and from bond to atom we deposit a negative. Now the second movement, from atom to bond, then from bond to atom. From atom to bond deposit another bond, while from bond to atom deposit a negative. Now another movement, from atom to bond deposit another bond, and from bond to atom deposits another negative. Now from bond to atom deposits another bond, and from atom to bond it deposits a negative. This is one complete resonance. Bond to atom deposits a negative, and atom to bond deposits a bond. So this will be the end of today's lecture. I'm so very sorry for making it this brief, but inshallah we shall continue from here next week, bi-iznillah. I'm very sorry for any inconveniences this might have caused anyone, but we just have to manage. Thank you very much all for your time, support, cooperation. Thank you once again, Sir Muhammad.